one is going to be what we call central angles, and the other one will be inscribed, which you guys saw in your vocab sheet last time. But this time we're going to talk about like finding out measures and things like that. So first up is central angles. So central angles, remember, are angles that have their vertex at the very center of the circle. And remember that we also talked about where the intercepted arc is, I think we talked about that. So like the piece of the arc that's in between the angle arms is what we call the intercepted arc. And the intercepted arc degree measure is always the same as the central angle, which is kind of a cool fun fact. So the intercepted arc degree measure is always the same as the central angle. It's like if this is 50 degrees wide, this is 50 degrees wide. And this is for every time you have an angle when the vertex is on the center of your circle. Okay. Yeah. Okay. So, for example, we are going to solve this problem, but before we look at anything over here on the right, my strategy is always to fill in everything I can on the circle, and then I fill in like what it's asking for. Because what it's asking for doesn't necessarily go in order of like figure this out, then you can figure this out. Like it doesn't go like that. So we'll fill in everything we can on the circle, and then we'll fill in what it's asking for. So the first thing I look for is central angles that I have a measurement for. And we have one right here, 136. So what I'm going to do is I'm going to kind of sketch out the edges of my 136 degree angle so that I can see where the arc is in between my angle arms. Okay, so the intercepted arc is this piece right here. So if this angle is 136, how much is the arc? 136. There you go. Okay, are there any other central angles that we have a measurement for? The 90, right? We have the 90, even though it's not a number, we know that box means 90. So let's do the same thing. Let's go ahead and sketch out the edges of that angle to see where the arc is.
What about the 62?
So the 62 goes from J to K.
But the whole thing is 90. So the I to J would be 20.
Yes, good. So the whole thing is 90, because that's everything in between the angle arms. If this is 62, well, 90 minus 62 is 28. That leaves us 28 for the little piece over on the left side. So from I to J is 28, because the whole thing was 90. Okay, do we have any other central angles that have a measurement? No. So at this point, your next strategy is to look for semicircles, because how much are semicircles? 180, right? Because it's half the circle. So for example, one example of a semicircle is like this entire top half, right?
So 180 minus 136.
So 180 minus 136 is this bit. Yeah? So let's see, what would that be? 44? All right. And then, of course, we have this semicircle on the bottom half too, but we have two missing arcs, so we can't quite do that yet. But here's your other strategy besides semicircles. Vertical angles. Excellent. Remember, vertical angles are angles that cross each other in an X, and they're always the same. So if this one is 44, this one's 44.
So the angle LPK would be 44.
LPK, yes, good. Yes, because the central angle is always the same as the arc measure. Awesome. Which then, since we only have one other missing piece in the semicircle, now I can say, well, 44 plus this 90 plus the missing piece should equal 180, because it's a semicircle, right? So thank you. So 46. Excellent. So it's kind of like a puzzle, right? Okay, so now we'll go over here and we'll fill in what it's asking for. So arc HL, that's the one that I have up here in blue. That's 136 degrees. LPK, 44. Let's see, arc KL, also 44. And arc IJ. Let's see. Yep, 28. Awesome. Cool. You guys tracking with me? Mm-hmm. Awesome. Sweet. Let's see. Oh, wait, there's more. I was too zoomed in. That's funny. HN is 44. Let's see. IN is 46. JL, so for JL, we're going to have to add a couple things together, right? So JL would be 62 plus 44, 106. And then HJ, same thing, we're going to have to add some things together. H all the way to J.
It's 118.
118? Okay, awesome. Fabulous. Okay, so if you want to write down your other strategies that we use where the semicircle is 180 and that vertical angles are congruent. So if you get stuck ever, go back, look for semicircles, look for vertical angles. Okay, thumbs up if you want to try the next one on your own. Thumbs down if you want to try it with me. Okay, I'm seeing mostly thumbs up. So try the next one on your own. If you have questions or get stuck, let me know. I'll come assist you.
So because the space on this one is 70, so these are both 70. And then you use the semicircle, add 70.
Oh, to find that one.
Yeah, to find
And
out
that
what,
was
and
the
these
same
are,
thing.
and then you just do 180 minus 62.
So, yeah, there you go, and write down the measurement of 7 to 75 because this angle. Oh, wait, no, HML will be that 70.
For the HML, did you get 260?
No, I got 180.
So,
Because you shouldn't be doing it this way. It should be not like using this, not that.
The angle would be in, right? So you would add up 62, 70, 70, and 62
What math are you doing next year?
to find this angle right here.
Just algebra 2.
well, you know, highlight for you. So these are your
Angle would be at
118.
Where'd you find that?
180 minus 62.
I think actually all my classes.
Where'd you get 62?
From that. What we found earlier.
Look, that's the
semicircle. Find this part of the semicircle.
But it's asking for.
Minus 62.
But it's asking for. Yep. Oh.
Already flipped over. Okay, I'm gonna go ahead and talk through it. If you're not finished yet, that's totally okay. So the first thing remember that I start with is, do I have central angles with a number on them? I did. So since that angle was 70, the arc is also 70. I also had another arc with a number on it, so I'm tracing the edge of that arc back to my angle, which means this is 70. I have no more numbers already on the paper, so now you're looking for semicircles. So yes, we had semicircles. I can split my circle down this line right here and say this is a semicircle. So 70 plus something equals 180, which means this is 40. Whoops, that's too big. 40.
What? How do you have 40? What did you?
Because 70 plus 7 is 140.
I might have accidentally done my short.
That's okay. So once you look for semicircles, you're also looking for vertical angles. So these guys are vertical angles, which means it's the same. Which means now we can solve for the other semicircle. So 40 plus this bit is 180, which makes this 140, which makes this angle where the M is also 140. So if we fill in the letters to the side, IJ is 70, JMK is also 70, HI is 40, LK is 40. Let's see, angle JML, that's 110 because that's starting here, going to the center and coming out. So it's adding my 70 and my 40 together. HML is 140 and HL is 140. Okay, real quick. On a scale of 1 to 5, how good are you on what we've done so far? Okay, sweet. Awesome. All right, then we're halfway through. Let's flip over to the back. Let's do inscribed angles. All right. Okay, can you pause your side conversations real quick? Thanks. Okay, so inscribed angles. Remember that inscribed means the vertex is on the circle. So this angle right here is inscribed because its vertex is on the circumference of the circle. So inscribed angles are half of the arc that they intercept. Or you can think of it the other way, as the arc is double the inscribed angle. I've heard someone say it before, the arc is double the start. Ooh, because it's kind of a half rhyme. So arc double start for the inscribed angle. So let's look at some of these. Now, there's a lot going on in this picture, hence why I gave you highlighters, because we're going to start the same way. We're going to start by tracing out the inscribed angle. So let's start with the 52, just because I like that number best, I guess, no particular reason. Let's trace out that 52, so pick a color. Trace out the edge of the 52, past the edge of the circle, so that we can highlight or color the arc that's in between the angle arms.
How did you find it? Huh? That's very,
It could touch the circumference.
that's very impressive, Christine.
So you're start where the angle is. You're going to color its arc all the way out. Color it all the way out. Everything in between your angle arms, you also color. And since the arc is double the start, how much is the arc? 104. Awesome. Okay, pick a different color. We're going to do the same thing, but let's do it for the angle that says 21. So I'm going to start at the vertex or the corner of the angle, and I'm going to trace the angle arm all the way until it passes the edge of my circle. So the arc in between is AE,
Oh.
because that's what's in between my angle arms. It's like imagine your angle arms clapping wherever their hands would move.
Oh, I did the wrong angle.
So AE, arc is double the start, so that would be 42.
Oh, because 21's the little, like, thing.
Yes, yeah, because 21 is the angle that we started with. Yeah. Okay. We're also going to need to find angle 1. So now I'm wondering if we have enough information for angle 1 already. So let's check it and see. So pick a different color from your table. And we're going to trace out the edges of angle 1. So start at the corner of angle 1 where it sits on the circle, and you're going to trace out the arms of angle 1 all the way until it passes your circle.
Oh. Wait, what's it again?
So start at the angle 1 on the corner. It is BF again. Trace out the angle arms all the way till it passes the circle. And you can see, yeah, between those angle arms is BF. So this is the arc. The arc is double the start. So what should the start be?
52.
52. Excellent.
You just add up all the sides of it. Wait, what's a full circle? Like the outside of a circle.
Full circle is 360.
So you just do all that minus, or 360 subtract.
Yeah. You guys see what she's saying? How we just have one arc that we don't have any numbers for? Because everything will add to 360. So we're just going to add 42 plus 75 plus 41 plus 104. Subtract from 360, and that's the arc piece that we're missing. That was a great idea.
Whoa, the next one? 360?
Yeah. 98. I get that.
Minus all this stuff and this stuff.
I'm good, 98. Wait,
How'd I get 98?
Yeah, it's not.
wait, 98.
98, yeah.
Oh,
98,
wow.
yeah.
98.
I'm amazing.
Okay, so let's see if we have everything it's asking for. So let's see, BF is 104. AE we have marked as 42.
Oh, it's because I did something.
That's okay. Ooh, EBD. We actually don't have EBD yet. So let's trace out that angle. So remember, to find the angle, you can trace it with your finger. So E to B to D means that your angle is up here at the top. So I'm going to trace out the sides of that angle, and let's see what arc it intercepts. Yeah, it's intersecting 75. The arc is double the start, so divide by 2, 37.5. Awesome, so EBD is 37.5 degrees. Yeah,
For 98, did you just add all of them and subtract them by 36?
I did, yes. Let's see, angle 1 we already found is 52 degrees. And AB we found is 98 degrees. Awesome. So, tips for this one would be trace out those angle arms with colored pencils. Remember that the whole circle will add to 360. And fill in the whole circle before you come over here and fill in these pieces. I think that makes it easier. Questions on that one? Let's see. I think these are trickier than the ones we did before. So I'm going to do example 4 with you also. And then it might be lunchtime probably after that.
Okay.
Okay, cool.
I'm okay with that.
All right, so example 4. Start with the inscribed angle you have the number on. So let's trace out the edges of the 15.
But does it not make a whole triangle?
15 also is part of a triangle. We might use that later. So the arc in between my angle arms is ED.
30.
So that's 30. Excellent. Because the arc is double the start when your angle is inscribed. Let's see. Okay, I have no more inscribed angles with numbers on them. So I'm going to switch to looking for semicircles.
Oh, is B to E a semicircle?
B to E cuts the circle in half because it goes through that center dot. And the top part of the circle, we don't have enough up there to solve using the semicircles, but down here, how much should B to D be?
130.
Oh, it needs to be something.
150. Oh my goodness.
Yeah, so this whole piece right here is 150. Okay, let's see. Let's pick another angle we could find. I'm going to pick, let's solve for this angle down here. I'm going to trace out the angle arms of this one. So I'm tracing out the angle arms of that angle because I want to see where the arc is. That's between the angle arms.
Is that just 180?
Yeah, right? This arc that's in between those angle arms is half the circle. So it's 180, which means how much is the angle that we started with?
90.
90. Excellent.
Oh my goodness.
And I don't know if it's going to ask for this or not, but how many degrees do triangles always add up to? 180. So guess what? This right here, we started with a triangle. So 15 plus 90 plus something also should equal 180.
65. 85.
75.
75.
Wait, oh yeah, 75.
75? 75.
It's okay, no.
Okay.
So does that mean that CBD would be?
CBD. Ooh. Okay. The question was, what is CBD? That angle. I'll trace out the angle arms.
Whoa. That's fascinating.
So CBD is still an inscribed angle because its vertex is on the circle and it's intercepting this arc right
so
here.
It's 150 divided by 2.
150 divided by 2. Excellent. So 75.
She's being a tryhard.
I like it when people participate and think. It's awesome. Okay, I don't know what it's asking for, so let's go ahead and see if we have everything it needs, and we can come back and fill in more if we need to. So let's see. DE we already found, so that's good. That was 30. DB we also found. That was 150. Let's see. Angle DEB. Remember, you can trace it with your finger if you're not sure where that is. Start at D to E to B. Yep. Where your finger turns is where the angle is.
Is it
Okay.
just 180?
You think that's 180?
Let's see.
Is BFB just 180?
Oh, I'm not there yet. I'm at BDE. BDE is 90.
CBD is 75.
CBD. Yep, CBD is 75.
But it's like it's all the way across. So is it just 180?
It is. BFE is a semicircle because it's all the way across.
It's all the way. It's a circle.
Yeah, because this is the line that split our circle in half. So we start at B, F, all the way back to E, where it started splitting.
Oh, I thought it was. Oh, it literally said that.